Welcome, dear students. Today we'll be talking about the position of a point, a straight line, and a circle with respect to another circle. Let's start by the position of a point with respect to a circle. If you can see in this circle that M is the center of this circle, where R is the radius. If MA is equal to R, then A is a point on the circle. If MB is less than R, then B is a point that is inside the circle. If MC is greater than R, then yes, good job, C is outside the circle. If you can check on this figure that is on the screen, you will see that M is the center of the circle, so this circle is named as circle M. The distance between the center of the circle and the straight line is the perpendicular distance from the center to the line. You will see that here MA equals R. Then this line is tangent to this circle, and this point we call it the point of tangency. Point A, we call it the point of tangency. In the figure that you can see in front of you, where MB is less than R, then this line is a secant. Secant means that this line goes inside the circle and meets the circle at 2 points. So here, L intersects M at points X and Y, where L intersects the surface M at the segment XY. In another case, we have MC is greater than R. Then automatically, point C is outside the circle, and this line is outside the circle. Then L intersects M with no intersection. So the intersection between L and M is phi, where the intersection between L and the surface M is also phi. Let's check some important facts. A tangent to a circle is perpendicular to the radius at its point of tangency. Any tangent, when it meets the circle at the point of tangency, it forms a right angle. So we call it, they are perpendicular to each other. If a straight line is perpendicular to a diameter of a circle at one of its endpoints, then it's a tangent to the circle. If a straight line is perpendicular to a diameter at any of its endpoints, then this straight line is a tangent to this circle. Another fact, if two straight lines are drawn perpendicular to a circle from the endpoints of the diameter, then these two lines are parallel to each other. Let's go and check this example. In this figure, you will see that circle M has a radius of 5 centimeters, where XY equals 12 centimeters, and MY intersects circle M at point Z, where ZY is 8 centimeters. The question wants you to prove that XY is a tangent to circle M at point X. Now, as you can see that the radius of this circle is 5 centimeters, then all radii are equal in length. So MX equals 5 centimeters, where MZ is as well 5 centimeters in length. So if MZ is 5 centimeters, you will see that the whole MY is 8 plus 5, which is 13. So now, to check that it is a tangent, if it's a tangent, it will form a right angle at angle MXY. So let's check this. You will see that. How to check the right angle? Yes, the Pythagorean theorem. So we're checking that MY, which is 13, MY squared is 169. So you will see that XY all squared plus MX all squared is 144 plus 25, which is 169 as well. So the hypotenuse squared equals the sum of the two legs squared. So MX is perpendicular to XY. As long as MX is perpendicular to XY, then XY is a tangent to circle M. Now let's move to another part, which is the position of a circle with respect to another circle. If you can see here, we have two circles, M and N, on the plane. The radii are R1 and R2. We'll see that R1 is greater than R2. So if Mn is greater than R1 plus R2, then there is no intersection between circle M and circle N. So the intersection is phi. So the intersection between surface M and surface N is also phi. So the surface of circle M intersects surface of circle N with no intersection. If there is no intersection, so it's phi. So these two circles are at a distance of each other. In here, if we have circle M and N are two circles on the plane, R1 and R2 respectively, where R1 is greater than R2. So here, if Mn equals exactly R1 plus R2, this means that, as we're going to see here, that these two circles, yes, are tangent to each other. So the intersection between the two circles, M and N, is at point A. So here, the surface of circle M intersects the surface of circle N, yes, exactly, at point A. So this means that these two circles are touching externally. Another case where R1 minus R2 is less than Mn, less than R1 plus R2. So in here you can see that the intersection between the two circles is points A and point B. The surface of circle M intersects the surface of circle N at, yes, exactly, segment AB. So these two circles are intersecting. If Mn equals R1 minus R2, as you will see now, yes, exactly. So M intersects N at point A, and the surface of circle M intersects the surface of circle N at, yes, thank you very much, the surface of circle N. So this means that the two circles are touching each other internally. Another case where you will see that Mn is smaller than the difference between R1 and R2. So Mn less than R1 minus R2. Then here, as you can see, there is no intersection between the two circles. So the intersection is phi. So M intersects N equals phi, where the surface of circle M intersects the surface of circle N at, thank you very much, surface of circle N. So here in this case, circle N is inside circle M. So circle N is inside circle M with no touching at all. Here, if you can see that Mn equals O, then M intersects N equals phi, where surface of circle M intersects the surface of circle N at surface of circle N. So this means that these two circles are concentric. Concentric means, again, that they are having the same center, or the two centers are in each other. Let's go to two important corollaries. The first one says that the line of centers of two touching circles passes through a point of tangency is perpendicular to the common tangent. As you can see here, this line comes from Mn passing through the centers and meeting this tangent outside the circle, so it's perpendicular to this common tangent. Where the second one says, the line of centers of two intersecting circles is perpendicular to the common chord and also bisects it. Dear students, now we came to the end of our session. Thank you very much and good luck.